By morning, more than 1,700 people were dead, but nothing had exploded. There was no conventional volcanic eruption, no battlefield, no visible warning. Whatever killed them had come from a lake, and scientists would eventually discover that the lake had been storing the killer beneath its surface for years. But what made it release it that night? Lake Nyos sits in northwestern Cameroon, surrounded by hills and communities that had lived in the area for generations. From the surface, there was little to suggest that anything was wrong. It looked like a lake, quiet water, green hills, animals grazing nearby. But beneath the surface, something was happening that nobody living around the lake could see. Lake Nyos occupies a volcanic region. Deep underground, geological processes were supplying carbon dioxide, or CO2, into the surrounding groundwater. Some of that gas eventually entered the lake, and because of the conditions deep beneath the surface, enormous amounts of carbon dioxide could remain dissolved in the water instead of immediately escaping into the atmosphere. The lake was slowly accumulating gas year after year. From above, almost nothing changed. There was no warning siren, no smoke rising into the sky, no obvious sign that the water was becoming dangerous. Just an ordinary-looking lake quietly storing something invisible. And then came August 21st, 1986. That night, something happened deep within Lake Nyos. The exact trigger remains uncertain, but whatever initiated the event caused a catastrophic release of carbon dioxide from the lake's deep water. This was not an ordinary volcanic eruption. There was no river of lava moving toward the surrounding communities. Instead, a huge quantity of dissolved gas escaped from the lake. Carbon dioxide is denser than ordinary air, so once released in enormous quantities, it could move into the surrounding low-lying areas. And that is where people were living. The event happened quickly. People nearby were suddenly exposed to an atmosphere containing extremely high concentrations of carbon dioxide. Many lost consciousness, and by the time the night was over, the landscape around Lake Nyos had changed forever. When daylight came, survivors began discovering what had happened. More than 1,700 people had died. Thousands of animals had also been killed. The disaster had affected communities surrounding the lake and extended into nearby valleys. But one thing made the scene especially difficult to understand. The lake was still there. The hills were still there. The landscape had not been consumed by fire. There was no conventional volcanic destruction explaining the enormous death toll. Something had moved through the area, affected people and animals, and then disappeared. Investigators now had to answer a simple question: what had killed them? When scientists began examining the disaster, they had several possibilities to consider. They studied the lake, they examined the surrounding geology, they collected water samples, they analyzed gases, they looked at medical evidence from survivors, and gradually different lines of evidence began pointing toward the same answer: carbon dioxide. The gas released from Lake Nyos was determined to be primarily carbon dioxide. Scientific investigations found evidence that the gas had a geological origin, connected to deep magmatic processes beneath the region. But this did not mean that a volcano had suddenly erupted beneath the lake. In fact, investigators found no significant direct volcanic eruption responsible for the disaster. Instead, something much stranger had happened. The lake itself had become a massive natural reservoir for carbon dioxide. The gas had entered the deep water and it had accumulated there. Imagine looking across Lake Nyos from the shore. The surface looks completely ordinary, but now imagine cutting the lake open and looking beneath it. The deeper you go, the more pressure there is. Under those conditions, large quantities of carbon dioxide can remain dissolved in the water. More gas enters from below. The deep water continues to store it, and the surface can still look calm. For years, this process can continue without an obvious disaster. That is what makes the Lake Nyos story so unusual. The danger wasn't something that suddenly appeared on August 21st. The ingredients for the disaster had been accumulating long before that night. The lake had been quietly storing carbon dioxide beneath its surface, and eventually, something caused that gas-rich water to release its contents. The result was the disaster of 1986. But now investigators faced another question, one that was much harder to answer. Scientists could identify the gas, they could investigate its source, they could explain how it had accumulated, they could explain why exposure to extremely high concentrations of carbon dioxide killed people and animals. But what actually triggered the release? That question has never been established with the same certainty. The original scientific investigation described the triggering mechanism as undetermined. Several possible explanations have been studied. One possibility involves a physical disturbance in the lake. A landslide has been proposed as one potential trigger. Other research has examined internal instability within the lake and the conditions under which gas-rich deep water could suddenly rise and release its dissolved carbon dioxide. Another way of describing the event is a limnic eruption, a sudden release of dissolved gases from a lake. But these possibilities need to be separated from established facts. We know that Lake Nyos released a huge amount of carbon dioxide. We know that the gas had accumulated in the deep water. We know that the gas had a geological source. And we know that the release caused the deaths of more than 1,700 people. But we cannot honestly say that one specific trigger has been proven beyond doubt. And that distinction matters, because the real mystery isn't whether the lake contained carbon dioxide. The evidence for that is overwhelming. The mystery is what happened in those critical moments when the lake crossed the line from dangerous to deadly. You might think the disaster ended once the gas escaped, but scientists soon realized that Lake Nyos was still receiving carbon dioxide from below. The geological process had not stopped. The lake could continue accumulating gas. And that raised a disturbing possibility. Could the disaster happen again? Researchers began monitoring the lake carefully. They measured the concentration of dissolved gases in its deep water, and the measurements showed that carbon dioxide was continuing to build up. The problem wasn't simply something that had happened once. The source of the gas was still there. So scientists needed a way to remove the carbon dioxide before it could accumulate to dangerous levels again. The solution was controlled degassing. In 2001, scientists began using a pipe system designed to bring gas-rich deep water toward the surface. The principle was relatively simple. Instead of allowing carbon dioxide to continue accumulating deep beneath the lake, the system would release it gradually and in a controlled way. It was an attempt to prevent another uncontrolled release. But researchers had to monitor the process carefully. The lake itself had to remain stable. The goal was not to disturb the water. It was to gradually reduce the concentration of dissolved gas. Later measurements showed that controlled degassing could reduce the amount of carbon dioxide in the lake while maintaining the stability of the water column. Scientists continued studying and monitoring Lake Nyos because carbon dioxide was still entering the system from below. The lake was no longer an unexplained mystery. It had become a geological system that scientists could measure, monitor, and manage, but they could not rewrite what happened in 1986. Today, the Lake Nyos disaster is much better understood. We know that more than 1,700 people died. We know that a sudden release of gas occurred. We know that the gas was primarily carbon dioxide. We know that huge quantities of carbon dioxide had accumulated in the deep waters of the lake. We know that the gas was connected to deep geological and magmatic processes. And we know that the released gas moved into surrounding low-lying areas where extremely high concentrations caused fatal exposure. We also know that scientists developed controlled methods to reduce the amount of gas remaining in the lake. But there is still one gap in the reconstruction. Scientists can explain the lake, they can explain the gas, they can explain the deaths, but they cannot say with the same certainty exactly what triggered the catastrophic release that night. Several mechanisms have been proposed. Some are scientifically plausible, but plausible is not the same as proven, and that is important when telling a story like this, because the truth is already extraordinary enough. There is no need to invent a monster beneath the water. No need for a supernatural explanation. The documented geological process is more than enough. From a distance, Lake Nyos looks peaceful. Water, hills, green landscape. Nothing about the surface tells you what happened there in 1986. But beneath that surface, geological processes had been feeding carbon dioxide into the lake for years. The gas accumulated where nobody could see it. Then, one night, it was released. More than 1,700 people never woke up. Scientists eventually reconstructed most of the chain of events. They identified the gas. They traced its geological source. They explained how it could move through the surrounding landscape. And they developed methods to reduce the danger of another release. But one question remains. What exactly triggered Lake Nyos to release its hidden carbon dioxide that night?